Okay, so let's start with the new exercise on kNN, that is on naive Bayes. Now the data set that we are going to use is iris. Iris is a flower and which has all the qualities of doing a analysis on that. So let's start with this. Let's first clear all the outputs by going to kernel and then restart and clear output. Once you click on this, it will be cleared and then we can start. Right, it's all cleared now. So now naive Bayes 1, as we have learned that this naive Bayes is used for the classification purposes. This is an example of a nearest neighbor classification using naive Bayes method. This is a method that we are going to use. Now we are importing as usual all the necessary libraries, that is pandas, numpy, sklearn. Then within that decision tree classifier, also import decision tree classifier, then sklearn model selection, train test split, that also we need. Then matrix, again from sklearn we can import, then confusion matrix, accuracy. So all these required libraries have been imported in this. So we can keep on running it also one by one. Here when we run it, it may take little time because it is all trying to import. So once it finishes, then we will go to the next step. That is because the libraries are quite big, so it may take some time. So now it is over. So go to the next, that is this data set is an array. Now this is available as a part of the sklearn library itself. So we don't need, in fact you can go for this data set either by using the sklearn itself. From there the library itself has this data set, or if you have downloaded from internet, from Google, etc., then you can use it from there. So either way it is possible. But right now, since we are using it sklearn, we have taken from the sklearn itself. So from there we are importing this iris data set, load iris, right? So this is how we can go for it. Now we are just using it. So once we have all this data has been imported, so go for load iris. This again a function which is available in sklearn datasets based load iris, and this gives you the indication that the data has been loaded. Now once we run this iris data, you will see that the complete array is being displayed here. That means all the arrays, because the data is stored in an array, so all that is given to you just by giving this kind of a command, that is iris data, right? So that is how it is available. Now we want to know, this again is a part of the data exploration. So mind you that we are not doing any analysis so far, but it is all understanding the data. So iris.key, when we are going to run this, you will see that you will get all the variables, that is data keys are data, target names, description, feature names, and file name, right? So these are all keys. Then we are going to go into more details about the iris data. So for that, like I mentioned here, with this we can description of iris data set, print iris, and within square bracket DESCR, that is description. So we can run that and we will see that it gives you all the details, which is just for our information purposes, just for our knowledge. So you can see that it gives all the details: iris data set, iris plant data set characteristic, number of instances 150, total number of records are 150, 50 in each of these three classes, number of attribute 4 numeric, predictive attributes, and the class attribute information, what is the length, width, and of these various kinds of like Setosa, versicolor, Virginia, etc. Then summary statistics also you are getting, minimum, maximum, mean, standard deviation, class correlation, etc. Then missing attribute values, class distribution. Creator was R.A. Fisher. That was he created it. He identified the flower way back in 1936. It's more than almost close to 90 years. Donor was Michael Marshall in July 1988, and the famous IRIS database first used by Fisher. The dataset is taken, right? So all this are for historical purposes. We are not going to do anything on this, but certainly for our information and knowledge, this is quite important. So this is all the details which are available, stored already in the dataset, but we are not going to use it. Now the data in the array can be converted in columnar data with following code. Now since this is all in arrays that we have seen, like here, if you see, these are all array, but array we cannot use, we are not going to use it. So we have to transform it, convert it into columnar type of data, as you know that the database looks like. So we are going to convert that into this. So first we run this, then we are going to, this is the data frame. So to convert that, df is equal to pd is the pandas, data frame iris, data columns is iris, and feature name. So whatever features that we have seen here, all those will be available to us. So let's run this. We can do that, and now we are going to check our top 5 rows, that is df head, because df is the variable which we have created for storing all these data sets, right? So if you run this, you will get that head. So you can see that now it is available in the form that we can use for our analysis purpose. So this is sepal length, sepal width, petal length, petal width. That means a flower has both, horizontally and vertically, the lengthwise. So that information is available to us. And since we are having only top 5 records, we are getting this kind of a output. Now the value with key target names is an array of strings containing the species of flower that we want to predict, right? So this is what we can, so now we can go for iris target names. So what are those names which we want to know? That is, this setosa, within that array, setosa, versicolor, these are the 3 types of flowers that we are considering, right? Data types is this. Now the features are list of features giving the description of each feature. So iris feature names, again we can get from this with this simple command: sepal length centimeters, sepal width centimeter, petal length centimeter, and petal width. These are for each of these flower types, right? So again we are going to get the data set, and then you can now see the numpy, and this is n dimensional array, right? This is just for information again, but yes, we can have the type of the data which is actually available, because we have converted from array to the columnar data with the use of that command. So now you can find out the shape of that. So shape means that how many rows and columns are there. So total number of rows are 150 and 4 are the columns, right? As we have seen here, if you go back here like this, 1 2 3 4 columns, and these are the rows. So 150 rows are there, because there are 3 types of flowers and each flower has 50 records. Though then we can go for this of course we have seen. Now the iris data we can have, we can also check it with the array. Whatever array was there, only 5 records we are seeing, so 5 records are being shown in the array. Now iris target, we can see that again this can be seen as in the array form. Again this array, and these are all your 50 records, and these are 3 types of flower, that is 0, 1, then 2. All these are available. This is again just for information, but we must know all this, right? So from sklearn, now model selection, import train test split, which is our usual way of training and testing. So from sklearn we have imported sklearn model selection, importing train test split. Now we are trying to transfer, split the data. So x train, x test, y train, y test. Train test split will be again iris data set and iris target. So we can see that iris target will be there, and random state. Now we are not splitting the data here, but we are using the entire data set for that, right? So this way, this can be run here, and we can see that nothing is going to happen. Actually no result is coming, but something is happened inside, right? Now the output of the train test split function are xtrain, xtest, ytrain, ytest, which are all numpy arrays. Xtrain contains 75% of the rows of the data set, remaining 25% xtest. So internally it has done that. 75% of the rows for the data set, remaining 25% contains the xtest. So again we can see the shape of the data, and now we can see that 112,4, that means 112 rows are available because we have divided into 75 and 25 ratio, which is internally done. We have not given it, it has been done by itself. And 4 columns. Now go for x test shape, that means whatever data is put into x, that we can see the shape of that. We can see that 38 rows and 4 columns. Right, now here, now we are going to apply a classifier through, though there are number of classification techniques available, but we will use k nearest neighbor classification technique. So from sklearn, now we are going to import k neighbors classifier. Now this is the library that we are going to import, which is part of the sklearn and then neighbors. So we can import this for our purpose. Now next is kNN is equal to k neighbors classification, and then n neighbors is equal to 1. So this is a code that we have to write, because we can after importing all that, then we are going to transfer it into kNN, right? So this side also we can run. Now we have to fit this to our we have to train the data, and by fitting it. So when you write this code, that is kNN.fit xtrain and ytrain, both these type of data can be taken into our this code. So you can see that it gives you the result, that is k neighbor classifier algorithm automatically it has been done. That is what we have seen. We have not given any 75 is to 25. It has been done. Leaf size is 30. Metric is Minkowski. Metric programs is equal to none. N jobs none, and n neighbors 1. P2, and then weights is uniform. So this is the kind of output that you get, right? Now next is that we are now going to see the new x new. So for that we are going to import numpy as np. Since it is already there, you may not do it, but it is always better to do it, otherwise it may give some error. So we can run it, and now you can see the new shape is 1,4, right? Now to make the prediction, we can call the predict method of kNN object. Now we want to predict. So prediction is equal to kNN.predict x new. So x new, which we have created as a where we have stored all this using this kind of a array data, that is 5, 2.9, 1, 0.2, etc. All that is stored, so we can use that for our prediction purposes. So when you do this, you will see that first you get an array which has nothing now left, because there is nothing is stored and nothing is left out. So we can say that array is equal to 0. Now once we are going to get the prediction to be used, like here we have got the prediction where which does not give anything. So iris target name gives you that. So you can say that array of setosa d type is equal to U10, that is again internal. We need not worry about that. So we are going to next we are going to find out the score of x test and y test. So once we do that, you can see that you are going to get as 97%, 0.9736 whatever. So 97% accuracy is there. So this is how we can calculate that. After doing all this exercise, we can say that, and this result has shown us that the 97% accuracy is found for this type of data. That is all these three types of flowers that we have, setosa, Virginia and versicolor. So this is the kind of accuracy is there with the k nearest neighbor mechanism that we have used. Thank you.